All right, so we are going to do a contour integral here. And the path that we're going to take, so this, let me preface this as saying this is a little bit of a ridiculous example. We're going to look at a circle of radius a half, centered here, and we're going to start at -1. We're going to go along that circle of radius a half, sorry, 1.5, until we hit this, so we do a half of a rotation. And then we're going to go from this point 2 to -1 plus I here. So we're going this way around it. And that's the contour integral we want to do. So we could do this. This is not necessarily hard. We'd write down a parameterization of the circle. It's somewhat simple to do. And then we write down a parameterization of the line segment. That's something that we know how to do. And we do them separately and we add them together. So we can do this. It's not challenging. It's just going to take some time. But let's notice here that 2z is entire. It's differentiable everywhere. So in particular, it's analytic on all of C. So it's analytic. So by the theorem in the previous video, this contour integral is, well, it's analytic on a simply connected domain, so it's independent of path. So this integral here is, I'm just going to say path independent. So let's take a specific path instead, and let's just go directly from -1 to 1 plus I. So if we let C1 be that path, then the integral over C2z dz is the same as the integral over C1 2z dz. Fantastic. All right, how do we parameterize C1? Well, with C1, you have a constant, a real part of -1, and then your imaginary part needs to increase from 0 to 1. So if we just stick a t on our I and let that vary from 0 to 1, this will do it. All right, so let's do exactly that. Plug our parameterization in. I guess let me just point out here, dz is, I think, I dt in this case. So this is telling us then that the integral over C1 2z dz is the integral from t equals 0 to 1 twice z dz. And so this is like 2I integral from 0 to 1, -1 plus ti, if we factor out the constants. And that's like 2I negative t plus t squared over 2I evaluated from 0 to 1. And plugging in 0 annihilates everything, so we just have to plug in 1. So we get -1 plus 1/2 I when we plug in 1. Let me just indicate that we did in fact plug in 0, but it goes away. And then I think where we're going to get is what, -2I, and then 2I times 1/2 I think is -1. So we get, if I'm doing this right, we get -1 minus 2I as our contour integral. And we did that without having to do all the nasty parameterizations. We just picked a convenient one because we knew our integral was path independent.